Oh, so sorry for the interruption. You know, New Zealand is a busy place. Anyway, so we are dealing with one of these triangles. So how can we compute the area of this little triangle? So its sides are A and B, and we know the formula for the area of a triangle is 1/2 base times height, because this is a right triangle. The base is actually A, right? You see A on the bottom, and then we know for a fact that B is the height because we have a right angle. So then instead of using that formula and our specific triangle, we come up with that the area of that triangle is A times B, 1/2 of that. Okay, and then it says what is the area of the square? The area of the square, because one side is C, then is C square. Now we move on to the second page. Well, before we move on to the second page, I'm going to show the camera the paper so that everybody is clear on what they're supposed to have. There we go. Okay, perfect. Now we flip the page. It says we have this concept called the area addition postulate. The area addition postulate states the area of a region is equal to the sum of its non-overlapping parts. And now that is going to be very handy in a little while, so keep that in mind. Now it says use the addition postulate to write an equation relating the areas of the 5 polygons and the big square. So remember we had that the area of the big square was A plus B squared because that was the length of a side, and then on the other hand we know that the big square is composed of these 5 little pieces. One square, which is C squared, that's the area of that one, and then we have 4 right triangles, and then the area of each of those was 1/2 AB. So this is our equation reads A plus B squared equals C squared plus 4 times 1/2 AB. Now it says solve the equation for C squared. So that's precisely what we're going to do. We're going to expand our binomial A plus B. So A plus B times A plus B is the same as A squared plus AB plus BA plus B squared. Now we're going to simplify this a bit. We can rewrite this as A squared plus B squared plus 2AB. That is because A times B is the same as B times A, right? No objection. 3 times 5 is the same as 5 times 3. Cool. Now on the other hand, we had C squared plus 4 times 1/2 AB. Now notice we can simplify. We can multiply 4 times 1/2, and that would give us 2, right? Now we're going to put together these 2 here, and then we're going to have A squared plus B squared plus 2AB equals C squared plus 2AB. So notice that we have AB on both sides, so we're going to get rid of that. We're going to subtract it so that they add up to 0. So then you have C squared is equal to A squared plus B squared, or we can rewrite it. C squared is equal to A squared plus B squared. There you go. That is the Pythagorean theorem. We proved this theorem. I'll show the camera so you can see all our steps. There we go. Okay. So now we're going to use substitution. Remember, in our original triangle, the distance it was D, the hypotenuse of the triangle we created when we sketched the lines. The hypotenuse was D. Now on this triangle, the hypotenuse is C. So they correspond, okay? So instead of C, I can put D. Now A is this length on this leg on the bottom. On the other triangle here, that leg was actually x2, the absolute value of x2 minus x1. So I'm just going to substitute that in. And similarly for the other side, I'm just going to substitute that in as well. Y2 minus y1. And so that's what we have. Okay, perfect. So we're almost there. This is the last one. Using substitution, use the theorem you proved in question 6 to solve for D. So we're going to just substitute these new values we have for C, A, and B into the Pythagorean theorem that we just proved. So we have, instead of C squared, we're going to put D squared. Instead of A squared, we're going to put absolute value x2 minus x1, and that's going to be squared. And then we're going to have absolute value y2 minus y1, that quantity squared. Now we can go in different ways. I'm just going to go ahead and take the square root first, okay? So if I take the square root, I'm going to do it in red, maybe just to show that this is a step I'm doing. So then I have d squared, and I'm taking the square root, so I'm just going to end up with d. Pretty sure everybody understands that. And then on the other side, we're going to have square root of x2 minus x1 absolute value, and then that quantity squared, and then same for y. Now here we can, this seems to be done, but actually we have the absolute value here. In our original distance formula, we don't have absolute value. See? Why can I get rid of the absolute value? That is because of a simple fact. Every number, any number that you square becomes a positive number. So you have -1 and you square it. That is the same as saying -1 times -1, which would in turn turn into 1. If you have 2 times 2, you come up with 4. If you have -2 times -2, it's also 4. So we can effectively ignore the absolute value. Is not needed, because at the end of the day, when I take the difference between x2 and x1, I'm just going to end up with some number, and that number squared is going to be a positive number. So the absolute value is kind of redundant here. So that is the logic behind just getting rid of the absolute value altogether. And so we end up with our long but beautiful distance formula. Now, as mathematicians, when we complete a proof, we fill in a little square at the bottom. Let me show you. So this is the last few steps. Sorry that I had to cut right in the middle. I got interrupted. Just for time's sake, I'm gonna show everything on this paper, just at the very least you have everything. If you have any questions, you're more than welcome to see this video as many times as you like. If still something is not clear, come to class or after school and we can talk. Alright, it was my pleasure presenting this very first video of me doing what we do in class, for those who are absent or for those who didn't understand. I mean, there's no shame. We do some very serious mathematics in class. It's not highly unlikely that everybody will get them right away. So this is me saying, yeah, I got your back. Okay, see you in class tomorrow.